Welcome to Brain Vision.
Welcome to a new problem on atomic fission, which pretty much means that you have atoms that are splitting from each other, the parts splitting to different pieces. So in this case, we have a particle A that splits from another particle B, and they fly off in opposite directions. So that's what we're given. We're given that the mass of A is ma, and the velocity of A is VA. It's moving in the negative direction, so it's negative VA. We're also given that the mass of B is MB, and the velocity of V is VB because it's moving in the positive direction. That's what we're given. So in part A, we want to find out the velocity of B. So find VB. Okay, find VB. Another thing we have to remember, these are final velocities. The initial velocity of A, we're going to call it VA initial, and then the initial velocity of B, we're going to call it VB initial. So these two happen to be 0.0 meters per second prior to splitting because the object is not moving yet before it splits. After it splits, then it acquires different velocities. So we want to find the final velocity of B in the first part, and then in the second part, we want to prove that the kinetic energy of A over kinetic energy of B have the ratios mb of so kinetic energy of A and kinetic energy of B have the ratios mb over ma. There are no losses of energy. Okay, so we're using the law of conservation of momentum, which pretty much says that the final momentum is equal to the initial momentum. The final momentum is the mass of A and the final velocity of A plus the mass of B times the final velocity of B, and this is equal to the mass of A times the initial velocity of A plus the mass of B times the initial velocity of B. Remember, this whole thing becomes zero because the initial velocities of both A and B are zero. The velocity of B, the velocity of A is a minus because it moves in the opposite direction. So that's going to change the character of this problem. So you have VA MA final plus MB VB final equals to zero. And so solving for the final velocity of B by moving in numbers, you get MA VA final over MB, which according to the book, you could, according to the way they want to structure the question, you could actually change it to just the mass of A times the velocity of A over the mass of B. But just recall that this is final. It's the same thing. It's the final velocity. That's what happens in part A. In part B of the problem, we're required to determine the ratio of the kinetic energy of A over B happens to be equal to the mass of B over the mass of A. That's what we're going to do in the second part of the problem. Remember, this has to do with the kinetic energies once they split. So when they split, we get to see that the kinetic energy of A is ma VA final over 1/2 mb VB final. These 1/2s will cancel out, And so we have MA VA final over MB. VB final was equivalent to all of that. So we'll have MA VA final over MB. So MA VA final over MB. And since it's kinetic energy, it has to be squared. The velocity has to be squared. So this is going to be squared and that's going to be squared. We simplify the problem. We get MA VA final squared over MB times MA squared VA final squared. This is MB squared. It's going to be MB squared. You can use that to simplify. Cancels 1. And then the VA final will also cancel the VA final. So you have MA times MB over MA squared. The A will cancel one of these, and that shows that eventually your final answer will be MB over MA, and that's what you wanted to prove. You wanted to prove that the ratios of the kinetic energies of A and B is the reciprocal, well, the masses of A and B, but flipped. Okay. Hope you enjoyed the problem. Have a wonderful day, and if you have any questions, feel free to send them my way. Okay, thanks. Bye.